been sent one of these recently, customer return. It's a 4.8 volt battery pack, AAA's, low self-discharge, capacity of 950 milliamp hours. Customer asked if I could have a look at it so you can do something with it. You can probably see from the connector now where I'm going with this one. I'll do it like that first. You can see that's deformed. By connector I mean the black bit on the top. That has been, it looks like it's been melted. I'm going to put a piece of paper behind it. Can that be focused upon? Not enough paper. Try and block out the rest of the background. Resisting that the urge to say focus you. Maybe that can go and focus, maybe. Let's try it like that. Can it be seen at all? I don't know. Take my word for it. That is melted. It's prompted the question, how much current can one of these little connectors take? This is a Futaba connector, used in servos and receiver connectors, radio control, that kind of thing. So how much current can they actually take before they melt? I mean, this is rated for 3 amps, I believe. But 3 amps, that is only half the numbers that I need. I mean, what's the voltage of it? These, I would have thought these would have been rated by power, which is volts and amps for watts. So I'm going to do a couple of little tests. Just thinking, this battery pack should only be able to discharge 2 amps maximum. That's not the short circuit current, of course, but in use. This connector is rated at 3 amps, so why is it melted? I'm going to see if I can charge this one up. I'll do another test at the end. I'll just short it out with a new connector and see what kind of current this can output. So for the test, I'm going to be using a new connector attached to a very big battery. These are D cells. It's still 4.8 volts, still 4 cells, but with a newish connector. The reason I've done this is because this battery pack can output, well, when they're new, about 35 amps, whereas this one can only output about 2 amps. That'll give me much more scope, so I can ramp up the current and see what its melting point is. And so for this test, you can see the load tester here. It's good to about 180 watts, which is 12 volts by something. But I'm going to use this battery, 4.8. I've also rearranged the pins on there so there's some space between them, and the same on that side. Let's hook up those. Yes. So, my little weather station. So ambient temperature. The date's wrong. You can ignore that. It's the middle of April. It's 48 degrees Fahrenheit. How much is that in new money? Not much. And because it's fairly chilly, I've got a steaming hot mug of coffee in there as well. Okay, shall we hook that up? Can you see that display from there? I'm assuming you can. So I'm going to hook this up. Well, make sure that I'll turn down to 0. Hook this up if I can. Okay, so it's showing 5.53 volts. I'm assuming you can see that. Where shall we start? 3 amp. I propose leaving this for about 10 minutes. Behind. That's close enough. Okay, so as ambient temperature at 3 amps, we'll give it 10 minutes to see what happens. So obviously these are cold to the touch in 48 Fahrenheit. So I'll come back to that in 10 minutes. So how long is that? 10 minutes? Where's my knife gone? So that's 10 minutes, let's call it 5 volts, 3 amps, 15 watts. I'm going to have a pick at this connector, see. Oh, still stone cold. See if there's got any softer. No, that's fine. Okay. Second part of the test, I'll zero that out. Let's give it what? 6 amps? That's close enough. Another 10 minutes. So that's been near enough 10 minutes. So it's 25 watts. So the voltage is dropping on this one. It's about 30 degrees C, maybe 25. Let's have a little pick at it. No, nothing. That's quite impressive. I thought that would have begun to soften at 6 amps. Obviously hasn't. Now I haven't got that much juice left in the battery. Let's zero that up again and let's give it more current. What should we go for? 10? Let's go for 10. See if the battery will take it. Oh, it's really dropping. 3.74 volts. It's down to 1.2, less than 1 volt per cell. Let's give it a couple of minutes and see what happens. Now that's really impressive, really impressive. 10 amps for further 10 minutes. Just to check the current, I've got a clock meter. 10.47 amps on that one. Some 10.1 there. I've also tested the temperature with it's one of these little guns. You can right on the connectors there. It was about 47 degrees. I probably can't show you that. Can I try? Battery pack is moderately warm. It's about 30 degrees. So let's see if you can show. Was that maximum? About 51 degrees, was it? 48. 50 degrees. I'm going to have a rethink now, aren't I? I expected that to start to melt, especially in 10 amps. See, I can pick away with that, but at 50 degrees, it's nowhere near starting to soften. So, as a former mouldist dealing with injection mouldings, I know these should start to soften. It's going to be about 120 degrees, 140, something like that. I mean, that's only warm. Before I was rudely interrupted by the camera running out of storage space in mid-sentence. I was just saying, while it was off, that the wires on these, they're 22 gauge silicon, good for 7 amps. Again, yes, 7 amps, only half what I want to know, but they were barely warm. One was taken, after taking 10 amps for 10 minutes. So I've had to charge this back up again anyway, so it's running pretty low. So let's carry on with the test. But let's go further. It was nowhere near melting last time. Shall we go for 20 amp? Let's see which gives up first. Battery or the wires or something else. So everything's zeroed. It's way past 10 now. 3.96, 13 amps, come on, give me 15. 15.5 amps. Let's see how long that goes for. That's below 0.9 per cell now, so we said 35 amps for these batteries. God almighty. Let's fully charge back. Anyway, let's leave it for a couple of minutes and see what happens. So that's run for 23 minutes. I think this battery pack has suffered enough. Let's get this final laser reading. 126 was creeping up a bit, but just not enough to melt it. Just off the bottom connector, off the back of it. And that's off the pins. 128 maximum move. 27. So let's have a rethink. So that's been what, between 40 and 50 watts for 23 minutes. Never expected that. The wires are nice and warm. Oh. Fairly hot to the touch. So let's have a rethink. I promised that I'd do this one, charge it up again if I can. So the customer said it had gone red hot when it was shorted out, so I don't know if it'll even take a charge. I'll do that in the next video. So this one's already going to be too long, and I'll try and short it out and see what happens. That's for part 2.